All right, this is AP, AB, and BC Calculus. We are doing Unit 4, Section 2, Straight Line Motion, Connecting Position, Velocity, and Acceleration. So there's a fair amount of vocab in this section. We're going to do the next two slides with a lot of vocab that I have color-coded, mostly just so that you can see the separate definitions on slides that have a decent amount of text. All right, so vocab. Position is a vector. It is a directed location. So x of t is often used for particles moving on the x-axis. Y of t is often used for particles moving on the y-axis. Sometimes it'll be s of t, or in the case of height, you might see h of t. We'll use x of t here just for convenience, but it could be any of those. It could also be something else. They could decide that it's the position of a cat, so they could use c of t for cat. I don't know. Anyway, it'll be defined differently in different problems. If there are units present, which is not always the case, but if there are, there'll be units of length, like feet, meters, inches, centimeters, miles, whatever. Again, it's a directed location. So for instance, if we were talking about a particle moving along the x-axis, right, and if this is 0, right, so this would be a position of 3, right? Like this would be the position where x is 3, right? This would be a position where x is -2, right? The part of it that makes it a vector is that it is a directed location. It's to the left or right or above or below a specific point, okay? So that's a directed location. Velocity is also a vector. Velocity is the change in position with respect to time. So in calculus, we learned that v of t is x prime of t. It is the derivative of position. So if present, units are length per time, like meters per second, feet per second, miles per hour, etc. If you're asked for the instantaneous velocity, that's calculus, instantaneous velocity at time t equals a, you would want v of a, right? So you'd plug in time a for the v function, the velocity function. If you're asked for the average velocity on the interval from a to b, well, that's actually like a third grade science problem, right? It's old school, change in position over change in time. So x of b minus x of a all over b minus a. Acceleration is also a vector. It is the change in velocity with respect to the change in time. So a of t is the same as v prime of t, which is the same as x double prime of t. The units, if present, it says in present, but we mean if. The units, if present, are length per time, like meters per second squared, feet per hour squared, etc. So sometimes you'll also see this as meters per second, like meters per second, because this is the velocity changing with respect to time, but that's the same thing as meters per second squared. If you're asked for instantaneous acceleration at some c, you would want a of c, right? Like a of c. If you're asked for an average acceleration, that's the change in velocity over the change in time, so it would be v of b minus v of a over b minus a on some interval from a to b. All right, so a little more vocabulary. Speed is a scalar. It is the absolute value of velocity. So speed is velocity without the direction. So velocity might be a -50 meters per second because you're falling out of something, right? So -50 because you're moving downward. But the speed as you fall downward would be 50 meters per second because, which is really fast. You're falling fast. So the idea is that speed doesn't have a direction. Speed is just the quantity. It's called a scalar. It is magnitude only, no direction. Displacement is a vector. It is the change in position on a given time interval. So it's essentially the final position minus the initial position. So on the interval from a to b, it would be x of b minus x of a, right? Sometimes it's also called net distance. You'll see displacement referred to as net distance. Distance itself is a scalar. Sometimes you'll hear it called total distance also, but distance in general is a scalar. It is the distance traveled by a particle on a time interval AB, and it's the sum of the absolute values of the displacement of each leg of the trip, meaning how far you traveled between stops. And we're going to talk about this a lot later on, but I wanted to introduce the concept that displacement and distance are different things so that when we see them later, we're not shocked. We're going to see a lot more of that when we learn integration in the second half of this course. All right, so some key phrases that you should definitely make note cards for. On one side of your note card, you should have the word initially. On the other side, you should have that means that time is equal to 0. So again, one side of a note card should say the word initially, and the other side of your note card should say, yo, that's when t is 0, right? It's at the start. The phrase at rest is going to come up a lot. At rest means that the velocity is equal to 0, v of t equals 0. And that's, so if the AP says this, you need to write this. Or think it if it's a multiple choice. Right? If it's multiple choice, you just have to think that it's true, but if it's free response, you need to write that you understand that this word means this thing, okay? And the same thing for all of these. If a particle is moving right or up, depending on whether you're moving on the x-axis or the y-axis, then that means the velocity is positive, so v of t is greater than 0. If a particle is moving left or down, that means that the velocity is negative, so v of t is less than 0. The colloquial phrases speeding up or speed increasing mean that v and a have the same sign. It doesn't matter which sign they are, and we'll talk about, let me walk you through an example of that in just a second. I'm gonna walk you through the logic behind this in a second. So speeding up or speed increasing means v and a have the same sign. Slowing down or speed decreasing mean that v of t and a of t have opposite signs. You will not believe how many times this communication is going to get you a point on the AP in a free response, because they ask you, when is this happening and why, and you justify your answer like this. So please memorize these words and phrases. Know that this is what they translate to mathematically, because just knowing that translation is going to bail you out of some AP free response. So let's insert a slide, and we're going to talk for a minute about speeding up and slowing down, because I don't think I put one after this. I did not. So let's talk about this for a sec. So let's talk about the logic of this speeding up and slowing down. So we're going to do that on an extra slide. Okay, so let's look at 4 scenarios, okay? One scenario is that, so scenario 1, I'm in a car and I'm driving forward. Okay, so I'm driving forward, which means that my velocity is positive, right? I see a yellow light. Okay, and I'm a bad driver, so I hit the gas. Now, hitting the gas is saying that my acceleration is also positive. I am absolutely speeding up as I approach that light, right? So my velocity was positive, my acceleration was positive, and I'm absolutely speeding up. Case 2, I am in a helicopter. I fall. So my velocity is definitely negative, right? I am moving down, right? You don't fall up, right? So I'm falling out of said helicopter, right? There's this thing called gravity, right? The acceleration due to gravity is definitely negative, right? It's a negative 9.804 meters per second squared, okay? I am absolutely speeding up as I plummet to my death. I think this is how you spell plummet. That's 2 M's, to my death, right? It's not pretty. It's kind of ugly. All right. So the speeding up is fairly intuitive, right? Speeding up, I'm moving forward. I hit the gas. I'm speeding up, right? Helicopter, I fall out of the helicopter, which means I have negative velocity because I'm falling down, and there's gravity and it's negative, and oh look, I'm speeding up as I plummet to my death. What is less intuitive for most people are the other 2 cases. So case 3, okay, same situation. I'm driving in my car. So I'm driving in my car. I'm driving forward. Same thing. So my velocity is positive. But now I see a yellow, and I'm a good driver, right? I'm cautious. I care about other humans. So I hit the brake. Well, if I hit the brake, that means that my acceleration is less than 0. Notice that velocity is positive, acceleration is less than 0. I am absolutely slowing down. That's the whole point of hitting the brake, right? I saw the yellow light. I said, oh, wait a sec. That's a thing I don't want to do. I don't want to run a human over. I don't want to run a bike over. I don't want to run anybody over. So I'm going to slow down. Okay, so that one's also fairly intuitive. 4 is the one that I think everybody struggles with. So let's go back to that helicopter, right? So I'm in a helicopter, and I fall, which means my velocity is definitely less than 0. But I open a parachute when I'm clear of the blades from the helicopter, right? Because we're not gonna, this gets really ugly really fast if I get sucked up into the blades, and it's not at all what I was going for. I open a parachute, right? And what that does is the drag from that chute means that my acceleration becomes positive. I never actually move upwards. My velocity stays negative the whole time. When you see a parachute open, it almost, like if you're the person on the parachute, it jerks your body and it feels like you're moving upwards, but you're actually not moving upwards. It's just that the jerk you feel is essentially because the acceleration changed quickly from negative to positive. And we'll talk about that. There's a funny joke about the third derivative position being jerk, which it is, but anyway. So your body is jerked what feels upward, but you're not actually moving upward. It's just that the change in acceleration was so fast that it feels like you moved up. So your velocity is still negative. You never actually start moving upward with a parachute. That's not how it works. It's just that the drag from the parachute changes your acceleration so it's positive, and sure enough, you're slowing down so you're no longer plummeting to your death, okay? So I mention this because understanding how these work, now you don't have to memorize how this works, right? You don't have to notice that it's, you don't have to actually think of all 4 of these examples every time it happens, but you're very likely on your AP going to have to justify something in this way. You're going to have to know that this is the relationship. You're going to have to know this stuff because these values are going to come up in a question, and sometimes they're also going to be used to justify this other answer about speeding up or slowing down, etc. So just be mindful that this is how these things work. Please make note cards about them. It's really, really, really useful. Okay, cool. Let's go ahead and do an example 1. Example 1, x of t is the position of a particle at time t. This is slide 1, by the way. There will be 2 slides of example 1. First thing we're asked to do is find v of t. So I want to communicate my understanding and recognize that v of t is the same as x prime of t. Write that down. I know it seems like a simple step, but if you don't write it down, that's a point. That's communication that you understand what you're doing. And then I just differentiate. So 3t squared minus 12t plus 0, that's it. Done. Congratulations. What time is the particle at rest? Well, notice they're not going to ask me to do this, but I need to communicate that this means v equals 0. That's worth 1 point on my AP. Please communicate that you know what at rest means, right? Now I'm going to factor to solve. I'm going to take out a 3t and be left with a t minus 4. So either 3t is 0 or t minus 4 is 0. T is 0 and 4. Now, here's the thing to notice. There were no units in this problem, so I don't need units. If you need this step and the answer. Nobody needs to see you factor on the AP. Right? Like it is assumed at this point that you know how to factor, and you are given the benefit of the doubt on the AP that you know how to factor. They're not going to think you're cheating if you factored, but you have to show the steps that communicate you understood something. This means v is 0. Show the steps that mean you know that's v is 0 and that you set v equal to 0. Show the final answer. Again, show the step that communicates what a of t is. A of t is v prime of t, or you could write x double prime of t, or you could write both. It doesn't matter. Either way, show that step that communicates understanding. A of t is going to be a 6t minus 12, right? But show the step that communicates understanding. All right, moving on to slide 2. All right, so I'm going to copy what my v of t was from the previous slide. I'm not really going to copy, I'm just going to differentiate again while I'm here. And I'm going to copy what a of t was because I'm going to need them, right? Okay, so what is the acceleration of the particle when the velocity is first 0? So the first thing I have to do is figure out when this happened. Well, we know from our answer to a previous question that the velocity is 0 at 0 and at 4. They said first 0. So what they're asking you for here is what is a of 0, the first time the velocity is 0, right? And so that's going to be 6 times 0 minus 12, which is just going to be a negative 12, right? No units because there weren't any units in this problem, right? Don't invent units that don't exist. Okay, next question. When is the particle moving left? So the first thing you need to do is you need to communicate your understanding. You need to say, oh, that's when v is less than 0, right? Communicate that understanding. That's worth a point on the AP. So then you're going to need to find when this thing is less than 0. There are a couple different ways to do that, right? I would argue that one way, since you already know that v is equal to 0 at t equals 0 and 4, and if you look at v of t, it's a parabola, right? This is a parabola that looks like this. It's a smile because the 3 is positive. So if you know that the 2 zeros are at 0 and 4, then you know this thing is negative in the window between them, right? So that's the window where v is less than 0. That's a negative velocity. So if you do it that way, you can say, okay, cool, the answer is 0 to 4. Or if you like it better, you could write 0 is less than t is less than 4, right? The other way to do this problem, right? So if you don't want to make a visual sign chart, the other way to do this problem is to make an actual sign chart, right? Which we did a lot of before AP Calc. So from negative infinity, 0 is a critical point, 4 is a critical point, right? So those are my zeros. My two factors are 3t, 3t is going to be 0 at 0. It is a line with a positive slope, so it's negative and then becomes positive. T minus 4 is 0 at 4, and again, it's a line with a positive slope, so it's negative before it hits 0 and positive after, which means that my v of t, which is the product of these two things, is negative times negative, which is positive. At 0, it will be 0. At 4, it will be 0. Positive times negative is negative. Positive times positive is positive, and this is your window, which is the same answer from 0 to 4. I don't care how you do it. I don't even care if you just did this in your head, right? As long as you communicate this information, it's not cheating to find a way to get to here, right? And then the last question is probably going to take a little bit of extra space. It's when is the particle speeding up? Well, this is tricky, right? Because remember, speeding up means A and V have the same sign. So what I'm going to have to do is I'm going to have to compare, oh, my bad. I'm going to have to compare the signs of A and V. I'm going to need to make a similar sign chart for A and see what's happening with A and then compare. So let's make a sign chart for A of t, right? A of t is just a line, right? So A of t was, if you want to take a 6 out, you can. It's a 6 times t minus 2, meaning that essentially this thing is 0 at t equals 2. A of 2 is 0, right? That's the only 0. So if you were to look at an A of t sign chart, or if you just picture what A of t looks like, because A of t is a line with a positive slope, right? So it's 0 at 2, which means it's negative before 2 and positive after. That's fine. What's going to happen is you're going to get that this thing, A of t, is negative and then positive, right? So now if you were to compare what these things look like, and we're going to inch down a little bit, so if you compare the two sign charts, right, essentially what's happening is if we put all of these numbers together, right, so if we make a combined sign chart, what we're going to be looking at is the values that were important on my sign chart were 0 and 2 and 4, right? And I know that V of t, based on the stuff I wrote in red, right, V of t is 0 at 0 and 4. It is positive, negative in the middle, and then positive again, right? I know from my sign chart that I did in blue that my A of t is 0 at 2. It was negative before 2 and positive after. So I was asked, where is it speeding up? Well, that means where the signs are the same, right? So those are my answers. So my answer to F is on the window from 0 to 2 because both A and B are positive, or sorry, are negative in that window, negative, right? And, sorry, stupid button on the side of the thing, and also from 4 to infinity because both A and B are positive. Kind of ran out of space. So now that's a pretty long problem, right? You're not going to be asked to do all of those on a problem generally. Like this is 6 parts and the last part took a lot of time, but I wanted to walk you through how that works. Now we're going to do a P1 that's the same kind of idea and then sort of keep moving forward with these kinds of problems. All right, so you try P1, pause me if you want, and then I'm going to go ahead and work through it, okay? So the first thing I want to do in A is I want to communicate that I understand that V of t is x prime of t, right? Communicate what you know, right? And then when I differentiate, I'm going to get 3t squared minus 8t plus 4, right? It's not a terrible plan if you wanted to skip down and do C next. Honestly, it's not awful to just do, so I'm going to, oh, I should have written an A, sorry. So A of t is just v prime of t, or x double prime if you like that better, so that's going to be a 6t minus 8. It's not awful if you just want to bust out the two where you're differentiating really quickly first. There's not much to them, you're just differentiating and that's the whole deal, right? So then for B, you are going to have to communicate some stuff, right? So for B, when you read at rest, you need to communicate that you know what that means. That means that v of t equals 0, right? So 3t squared minus 8t plus 4 equals 0. And now you're going to have to try and factor. If it doesn't factor, you're going to use the quadratic formula. I genuinely don't care how you factor. I just care that you factor right. If I pick -2 and -2, I get a -6 and a -2, which is a -8. So either 3t minus 2 is 0, which gives me t is 2/3, or t minus 2 is 0, which gives me t is 2. So those are my two times. Notice again, I did not have any units in this problem, so I don't have to invent units. All right, so let's go to the next slide. Oh, as a side note, when you justify your answers, let's go back to E1 for a sec, don't use pronouns. I had to clearly say that I was talking about a and v. Don't say it when you're talking about a function. There are too many functions in our problems at this point for you to use pronouns. Okay, so I'm going to need v of t, which I found on the other page, to be 3t squared minus 8t plus 4, and I'm going to need a of t, which I found on the previous page, to be 6t minus 8. So I'm just copying them up here so I have them. It's also worth noting that I found that v is equal to 0 at 2/3 and 2, right? Those are the three things I found on the previous page. I'm just copying them so I have them. So let's look at D first. D says, what is the particle's velocity acceleration when the velocity is first 0? Well, this is the first time that the velocity is 0. So what this question is asking you is, it's saying, what is a of 2/3, right? You have to spot that that's what it's asking. So that's going to be a 6 times a 2/3 minus 8, right? Well, that seems to be a 4 minus 8. Sorry, I missed an equal sign in the middle. So my answer is that a of 2/3 is a negative 4. Again, there were no units in this problem. Don't invent units. So that's my answer to D. E, when is this particle moving right? Again, your job here, right? So let's look at E. Your job is to communicate that you know moving right means that V is greater than 0, right? So there's a couple different ways to do it. V is another parabola with a positive leading coefficient. So there are two ways to do this comfortably, right? You could either say, oh, I know that V is equal to 0 at 2/3 and 2, which looks like this on a number line. And I know that V is a parabola with a positive leading coefficient, so V must look like this. Like, that's got to be V of t. So if I want when this thing is moving right, I want this window and this window. So if you see that, your answer is going to be negative infinity to 2/3, parentheses, and 2 to infinity, both in parentheses, and that's fine. If you prefer, you could make the old school sign chart. Doesn't matter to me, right? If you make an old school sign chart, you have your two zeros already, right? So the values that have to go on your sign chart are the 2/3 and the 2 in ascending numerical order. And my factors were 3t minus 2 and a t minus 2, right? So here's what I know. I know that 3t minus 2 is 0 here. It's negative before it crosses 0 and positive after, because this is a line with a positive slope, right? Same thing for t minus 2. It's going to be 0 at 2, and because it's a line with a positive slope, it's going to be negative before it crosses that 0 and positive after, which means my v is going to be positive, negative, and then positive, with it being 0 at both 2/3 and 2. So then the intervals I want are the same two intervals I wrote in green up here. So I don't care how you get there, that's the idea. Last question, I'm asked when the particle is slowing down. What I want to communicate is that I understand that A and V have opposite signs, right? That's what matters. That's what slowing down means. I need to communicate that information. So I already found a sign chart for V. I need to go ahead and find my value for A. And if you go up, A is 6t minus 8. So A of t is 6t minus 8. That's equal to 0 when t is either 8/6, or if you prefer to make it 4/3, that's fine. It doesn't matter to me which. Either way, it's a number that falls between these two. So basically, what's happening here is I have a 4/3, infinity, negative infinity. And you could factor out a GCF if you want, but basically this thing is negative before it crosses 0 and positive after, because it's a line with positive slope, right? So if I combine these pieces of information into one combined sign chart, right? If we make one big sign chart that has negative infinity, 2/3, the next smallest number was the 4/3, the next number was the 2, and then we have an infinity, right? If we look at my V of t sign chart, which was right here, V is 0 at 2/3 and 2. It was positive before 0, negative in between the zeros, and positive after. And then my A of t, which I did in blue, was 0 at 4/3. It was negative before it hit that point and positive after. Since I'm looking for the window where they have opposite signs, these are my two windows, right? So my answer to F is negative infinity to 2/3, parentheses, and 4/3 to 2, because A of t and V of t have opposite signs. And I need to say that. I need to say that they have opposite signs. That's important. You're not going to get full credit for this question without communicating that that's the mental leap you had to make when you read this phrase, okay? Cool. Moving on. Lots of math in these. All right, cool. So we're going to talk about connecting the graphs a little bit. So remember that in the simplest of terms, derivative is slope, right? So if you're given the graph of x of t, then the slope of that graph is x prime of t or v of t. If you're given the v of t graph, then the slope of that graph is v prime of t or a of t. The second derivative of a function determines the concavity of a function. So thus, if we're given the x of t graph, the concavity of that graph tells us about the second derivative or the acceleration. So when the x of t graph is concave down, x double prime of t, which is the same as a of t, is negative. When the graph is concave up, x double prime of t, which is the same as a of t, is positive. So we're going to walk through some problems that involve a graph. Okay, so the graph below is the position x of t in meters of a particle at time t in seconds. So now we do have units. What is the velocity of the particle at t equals 20? Okay, so remember, the velocity, right? So v of 20 is going to be x prime of 20, which is going to be the slope of the given graph at t is 20, right? So that's what we're looking for, right? V of 20 is the thing they ask us for. We're going to translate that's x prime of 20, which is the slope of this given graph at 20. Well, this graph is linear at 20. It has a slope of down one block over one block. You just have to make sure you look at the size of the blocks. So this is down 20, right? And then these blocks seem to go by 5s. So this is down 20, right 5. So it seems to be that v of 20 is down 20 meters, right 5 seconds, so negative 4 meters per second, okay? But it's the slope of the given graph, okay? At what times is the particle at rest, right? Well, remember, at rest, we have to translate that at rest means v is 0. So you hear particle at rest, your brain says, oh, when is v equal to 0? Well, what you translate from that is that's when x prime of t is equal to 0, which is when the slope of the given graph is equal to 0. So slope of the given graph is equal to 0. That's what you're looking for. So now look at this graph. Well, in this window, the slope is 0, and that seems to be the only time it's true. So the answer is from 10 to 15. So 10 to 15, right? Or you could have said the answer to B could be 10 seconds is less than t is less than 15 seconds, right? You could answer it in a sentence. Notice it's not included because at the ends, this graph actually doesn't have a slope. It's not differentiable at the ends. So that's the answer. All right, now keep in mind, the AP would be looking for you to maybe give them the answers when this graph is 0, but this graph isn't velocity, right? So when you're given a graph, you're not usually asked questions directly about the function graphed. You're usually asked about some function that is in some way related to the function that's graphed. All right, let's go ahead and do a P2. So you can pause me if you want. This is also a position graph. So go ahead. I'm going to go ahead and walk through it while you hopefully walk through it before you unpause me. So what is the velocity of the particle at 2? So remember, you're being asked for v of 2. I want your brain to make the leap that that is x prime of 2, which means that it is the slope of the given graph at t equals 2. So then look at this graph and say, oh, look, that's linear. It seems to be going up 20 and right 1. Right? So it seems to be 20 meters per second. So 20 meters per second, right? 20 meters per second. And make sure you have the right units, right? At what times is the particle at rest? Remember, your job in communicating understanding is to say, oh, that means v is equal to 0, which means that x prime is equal to 0, which means that the slope of the given graph is equal to 0. Well, that happens here and also here, right? Now, you kind of have to estimate that this is 4.5. We're just going to call it 4.5, right? So, so my answer is going to be starting at 0, because it is level at 0, right? But it doesn't, up until 1, because it's not actually 0 at this pointy thing. It's not differentiable. And also from 3 to, let's call it 4.5 on a real AP, they'd do a better job of giving you a value that you could see. All right, moving on. Okay, so y of t is the position of a particle moving on the y-axis at time t. So first thing we're asked to do is find v of t. So notice that this is going to be a product and a chain rule, right? Because it's a product because it's 3t times e to the stuff, but there's a chain because there's stuff inside the e. So my v of t, which is the same as my y prime of t, is going to be u. dv is going to be e to the stuff times the derivative of the stuff. So that's going to be e to the negative 2t times a negative 2, plus v, which is e to the negative 2t. du is a 3. So I'm probably going to rewrite this. If I yank everything out in front, it seems to me that I can yank out a negative 3e to the negative t. And what seems to be left is a 2t minus 1. Right? So I would suggest that you use the factored form. You don't have to. But I'm going to be asked in a second, like genuinely in a second, to find when this thing is equal to 0. So it's a lot easier if I use the factored form. This answer is technically right, but you're going to be asked to set this thing equal to 0. So my answer to A, there's my v of t, right? My answer to B, sorry, we'll do B in blue. So remember, it is my job when I read this phrase to communicate that I know what it means. Even if my v in part A had been wrong, I need to know to set that v equal to 0, right? So either negative 3 is 0, which is a lie, or e to the negative 2t equals 0, which is a lie. E to the stuff is always positive. So e to a number is positive, right, always. Or 2t minus 1 equals 0, so t equals 1/2. That is the only value when this particle is at rest. T is 1/2, and it's seconds because there were units. I was then asked to find A of t, which is going to involve differentiating again, so yay, more product and chain rules. It's up to you. You can either use this version that you have, right, or you can use the version that looks like this. I don't really care. So if you had cleaned up your v of t a little bit up here without factoring, you would have gotten that v of t was a negative 6t e to the negative 2t plus a 3e to the negative 2t. I don't care if you use this version or this version. Either way, you're going to have a product rule. So if I do it this way, I have a product rule here and no product rule here. So my a of t, right, which is just my v prime of t, is going to be u, so negative 6t. dv is going to be a negative 2 e to the negative 2t, right, plus v, which is e to the negative 2t, du, which is a negative 6. And then I have to differentiate this guy, so that's going to end up being a minus 6, because it's 3 times the negative 2e to the negative 2t. Okay, I'm going to need space. I'm not surprised. Okay, so if we keep doing C, right, so for C, I get that A of t is what seems to be a 12t e to the negative 2t minus a 12e to the negative 2t, because these two are like terms, right? And then lastly, I was not asked to find a window when something's speeding up or slowing down. I'm just asked at a specific moment is stuff speeding up or slowing down. So this is my C. This is C, okay? For D, I'm asked at t equals 2, is this thing speeding up or slow down? So in order to find this out, I'm not looking for an interval. I'm specifically looking at t of 2. So what I need to do is I need to find v of 2. I need to find a of 2, and I need to look at their signs. So I can find a of 2 right here. That's going to be a 24 e to the negative 4th minus 12 e to the negative 4th, which is going to be a 12 e to the negative 4th, or 12 over e to the 4th. That's greater than 0. I don't care what number it is. I just care that it's greater than 0. If we go back up to my velocity, right, I don't care which one you use for your velocity. You could use any of them, right? I'll just use this one, okay? So if I go back up to, actually, this one's easier. I lied. So I'm going to use the factored form. Doesn't matter. Really doesn't. Okay. So for my velocity, just remember that your velocity was a negative 3e to the negative 2t times 2t minus 1, right? So if I wanted v of 2, that would be a negative 3e to the negative 4th times, this will be a 4 minus 1, which is a 3. So I'm going to get negative 9e to the negative 4th, which is a negative 9 over e to the 4th. That's less than 0. So this thing's slowing down. So slowing down. And when asked why, because you have to say why, you're going to need to say a of 2 and v of 2 have opposite signs. That's the communication you need. And you don't want to say a of t at 2. You want to say a of 2. That's what the notation means, right? So you need to communicate that information. These are really likely to be the kind of questions that you see about particle motion on an AP. All right, moving on. P3. H of t is the position of a particle moving on the y-axis at time t. Find v of t, find the values for which we're at rest, find a of t, and then is the particle speeding up or slowing down at 1? So this is basically the same question, all right? So you go ahead and pause me if you want. So for a, my h prime of t, which is going to be my v of t, and remember, you need to say what they're looking for. You can't just call it h prime. You need to say, hey, I know h prime is the same as v of t. That communication matters. This is my u and my v. So my product rule is going to be u. dv is going to be a negative e to the negative t because of the chain rule, right? Plus v, which is e to the negative t. du is a 2t. So I'm going to get that this is a negative t squared e to the negative t plus a 2t e to the negative t. If you want to factor it, you can. I would suggest it's worth it. I'd probably yank out a negative t e to the negative t, which would leave me with a t minus 2, right? You don't have to, but again, it's very likely, and we already know because we've read the second question, that you're going to be asked to find when this thing equals 0. So it's easier. Any of these would have been fine, but this one's probably the best. For part B, you need to communicate that you know what this means. You have to say v is equal to 0. So then you're going to set your v equal to 0 and you're going to solve. So either negative t is equal to 0, which is t is 0, that's one answer, or e to the negative t is 0, which is a lie, because e to the t is always positive, or e to the anything is always positive, or t minus 2 is 0, which gives you t equals 2. If you jump from here to the two answers, nobody thinks you're cheating. Like if you can set them equal in your head, that's great, congratulations. A of t is going to be a bit of a headache on this one because I'm going to have a product rule, so I can't actually deal with a product of 3 things very easily, so I'm going to have to use this one to find a of t, and it's going to involve multiple product rules, and it's a headache, but it is what it is. So recall that I had v of t is negative t squared e to the negative t plus 2t e to the negative t, right? So this is my u, this is my v, and then I'm going to do the same thing in another product rule in a second for these, right? You can't really easily deal with a triple product, which is what this is. You could have just factored out the e to the negative t, I guess, and left the polynomial as is. But so it's like I have a u1 v1 and a u2 v2, right? Like 2 different product rules. So my a of t is going to be v prime of t. Again, communicate that information. So let's do the first product rule. U dv plus v du. That's my first product rule, right? I'll do the second product rule in green just to show that it's a different product rule because this is an awful lot of mathing, right? Plus u dv plus v du, right? And so now if we clean up my a of t a little bit, it seems to be that I have a positive t squared e to the negative t, that's this guy. I seem to have a negative 4t e to the negative t, right? Because this is negative 2t e to the negative t. This is another negative 2t. And then I seem to get a plus 2e to the negative t. Great. Super fun. Good times. And I meant that entirely sarcastically. If you want to factor out an e to the negative t, you certainly could. That's the only thing that factors out, right? If you want to factor out an e to the negative t, you'd get t squared minus 4t plus 2, which is also right. Okay, last question. We're going to take my v and a, and we're going to plug in 1 for both of them and see what kind of signs we get. So for d, we're going to extend this guy, right? So for d, right, I need to find v of 1. right? Well, I'm gonna go ahead and plug into this just because I can see it. That's literally my whole reason. So that's going to be -1 e to the negative first plus 2 e to the negative first, which seems to be just a single e to the negative first, right? Which is 1 over e. That's positive, right? That's like about a third. It's not actually a third, but it's about a third. My a of 1, right? Notice I didn't say a of t, I said a of 1. I'm probably going to use the factored version because it seems easier. Is going to be an e to the negative 1. This will be a 1 minus 4 plus 2, right? That seems to net to a negative e to the negative 1, right, which is a -1 over e. That's less than 0, so slowing down, right? So my answer is slowing down because v of t and a of t have opposite signs. So v of 1 and a of 1, specifically, I shouldn't have said of t, have opposite signs. That's the information you're going to have to communicate to get full credit. All right, cool. Moving on. E4, the velocity v of t of a particle moving on the x-axis is given. What is the average acceleration and what is the acceleration at t is 4? Okay, so these are two different questions, right? This question, right, so average acceleration, when we go to do A, is asking me for v of 6 minus v of 1 over 6 minus 1. Instant acceleration at t is 4 is asking me for a of 4. So you have to know that that's what those two things are asking for. So let's go ahead and walk through A, right? So for A, v of 6 is going to be 18 cosine of 6 pi, right, which is just an 18. V of 1 is going to be 3 cosine of pi, which should be a -3. So my average acceleration on the window from 1 to 6 should be v of 6 minus v of 1 over 6 minus 1. You absolutely want to communicate that that's what you're doing. You don't just want to write the numbers. So it's going to be 18 plus 3 over a 5. So I should get 21/5. Check and see if there were units. There were none given. Congratulations. That's it. When I go to do instantaneous acceleration, right, I know that v of t was 3t cosine of pi t, right? So this is going to be a product rule, right? So my a of t is going to be u. dv is going to be negative pi sine of pi t because of the chain rule, right? The negative sign is because the derivative of cosine, and the pi is because you differentiate the inside, right? Plus v du is a 3, right? The 3 is not inside, sorry, the t is inside the cosine with the pi, but the 3 is not, right? So I'm probably going to skip to writing it 3 cosine of pi t. Okay, so now I was asked what's the acceleration at 4, so a of 4 is going to be, well, honestly, sine of 4 pi is 0, so this whole thing's going to get wiped out, right? Plus a 3 times cosine of 4 pi, which is going to be a 3. Okay, so that's the average acceleration versus the instantaneous acceleration, okay? Now you can make your calculator do this, right? This is a problem that you could have your calculator differentiate to find the acceleration, right? If you had put in, so if you do math 8, right? So if you had done math 8, and I'll walk you through it in a sec, which is n derive, you could differentiate, I could put this in as y1 with respect to x at 4, right? In order to do that, I would have to put my y1 as 3x cosine of pi x, and then I could differentiate, right? So if you wanted to do that, right? So if you wanted to, you could. Make sure your mode's radian, obviously. You could do 3x cosine of pi x, right? And you could actually use it to find all of these values, right? If you wanted v of 6, in fact, you could quit out of this. If you go to graph, it's crazy looking, right? But if you hit trace and you want v of 6, you could hit 6 and you'll see quickly that that's the point. See how I got when t is 6, the output is 18. Now notice the variables in the calculator don't align with the variables I'm using. You have to make that mental leap. But notice that I was able to get that 18 out from my calculator, right? I can do the same thing if I hit trace and 1 and then enter. You'll see that I get -3 as the output, and I didn't have to do that, right? They don't need to see this work. They need to see that you know this, whether it's calculator or not. They understand you can do that in your head. Now I can either do math 8 to find the derivative, or look, I can actually do second calc, and I can pick 6, which is dy dx, at 4, which is what I wanted, and it'll do it for me. Now you'll notice it comes with a 2.99999. That's because your calculator is not actually differentiating. Your calculator is approximating, right? So your calculator is not actually differentiating, it's approximating. All right, last problem of this section. The position s of t of a particle on the x-axis is given by the equation below. What is the average velocity from 2 to 6? And what is the instantaneous, like regular velocity of the particle at 3? Okay, so again, your big job here is to communicate what's being asked. This question, when you do A is asking you, what is s of 6 minus s of 2 over 6 minus 2? You need to communicate that information, and then honestly, if you do the rest in your head, nobody cares. But you have to communicate this information. So s of 6, right, is going to end up being a 12 minus 7 all cubed, so that's going to be 5 cubed or 125, right? And s of 2 is going to be a negative 3 quantity cubed, which is a negative 27. So you're going to get 125 plus 27 all over 4. That's a 152. So 152 over 4, which you could honestly leave it as, but if you wanted to divide, that is a 76 divided by 2, so that should be a 38. We can double check that because honestly, there has not been enough coffee in my life. Oh, wait, quit out of that. 152 divided by 4. Great. There were no units. My answer is 38, right? If there are units, you use units, but there aren't any. I then also have to communicate that for B, I understand that just general velocity, right? This is asking me for V of 3 or S prime. Sometimes we accidentally use the wrong notation, S prime of 3, right? So I have to differentiate this. So remember, to find S prime, I'm probably not going to FOIL this out. I'm probably going to use the chain rule. So derivative of stuff cubed is 3 stuff to the second times the derivative of the stuff. So S prime of 3 is going to be 3 times, when I plug a 3 in here, I get a negative 1 squared times a 2, so I get a 6. Now you could have made your calculator do this, I just don't think it's worth it, right? You can make your calculator differentiate, but it's not likely you're going to be asked to on the easier problems like this. All right, cool beans. That is Unit 4, Section 2.